All right, folks, assignment number 21 is over function composition and function inverse. We're going to start with composition here, and I'm going to go ahead and do examples 1 and 2 here and in one video. So function composition and inverse. First of all, we have two functions called f of x and g of x, and it's really a two-part question. The first part of the question is to find what they call f of g of x. That little circle translates to the word of, okay? And then the other part of the question is going to be to find g of f of x. And this is actually what's called composition. To my knowledge, we have not seen these symbols together in this room. However, we have done this before, whether you know it or not. I think it was assignment 17. We talked about composition is where you put one function into another. And so, and this will be the notes page again that's been uploaded. The symbol f of g of x, which to my knowledge we've never seen before together, actually means f of g of x. This is this. They're the same thing. We have not seen this together until today, but we have seen this. So I'm hopeful that this would be a review for you of assignment 17, where we took one function and put it into another. So the logic at this point would be as follows. We've done this before. In math, we have more than one operation, or in this case, more than one function. Doesn't the order of operations say to do what's in the parentheses first? So you'd hopefully say, okay, outside function f, I'll get to you later. I'm going to do the one in the parentheses first. And wouldn't g of x be this expression over here, x squared plus 3x? Okay, so we do the one in the parentheses first. G of x, is that their expression on the board, isn't it? All right, now, what does it mean to say f of that expression? This is like assignment 17. Don't we go to the function called f and replace that expression wherever there's an x? So this is where, on assignment 17, same thing, we go f of expression would equal 4 times expression minus 5. All right, now here's the deal too. I think it says simplify your results. I'm going to keep things moving, all right? So I will just tell you that on assignment number 21, let's not require you to simplify them. I probably should, but we're in unusual circumstances here, and just to keep things rolling, I would assume you could simplify this by distributing and so forth. And that's beside the point. So, I should make you do it. I've decided not to. 10Q, you're welcome. All right, call it good. G of f of x, on the other hand, is the other way around. So the other half of this question, g of f, again, we have never seen that symbolism together. Maybe you have somewhere else. Maybe you've been doing math with other people. But g of f of x is g of f of x. And I'll say it again. We've never seen this together, but we have seen this. Assignment 17. So, very same logic. We'll do the one in the parentheses first. So this will be g of, f is this one. 4x minus 5, right? Don't overthink it. F of x, 4x minus 5, this expression. And then the logic from there would be, all right, let's go to the g function and replace that expression wherever there's an x, right? So wherever we see an x here, we're going to say what? Expression. All right, so g of expression taking the place of x, equals, ready? Expression squared plus 3 times expression. And again, same speech. I could require simplification in terms of foiling, distributing, combining like terms. That's all old mechanical stuff. I'll cut you some slack. Don't worry about simplifying these. I should make you do so. I'm sure if there's math people out there watching this, they're like, he's not going to make them clean them up. Hey, look, desperate times call for desperate measures, all right? You don't need to clean them up, okay? That's just the way it is. Okay, so look, we're done with example 1. Let's go ahead and knock out number 2 while we're at it. So all we're doing here is we're changing the two functions, but we're doing the same thing. All right, so this time f of x is 6x minus 2. Again, let's just call it that expression. And then g of x would be, let's just call it that fraction over there. All right, g of x equals fraction. So, same instructions. F of g of x, which by mathematical definition is equal to this. Again, I'll just take you back to the definitions. All right, f of g. So f, and when you do these, please label which one is which. You know, f of g, like I'm doing on the board. All right. So f of g is f of g. You do the one in the parentheses first. So if somebody said to you, what's g of x? I hope you would say, that fraction over there. All right? Let's just refer to it as that fraction over there. That's g of x, right? G of x, there it is, that their fraction. And then won't this be, isn't the logic here, go to the function named f and replace the x with, this time we'll call it fraction. All right? F of fraction. Fraction takes the place of x. So, f of fraction would equal 6 times fraction minus 2. Boom. Clean it up. I should make you. I'm not going to. You're welcome. All right. G of f of x on the other side. So this is the other half of the question. So g of f, the little circle translates to the word of. G of f of x. G of f of x. So g on the outside, f on the inside. Therefore, f would be performed first, and f of x is 6x minus 2. So now we're doing g of expression, aren't we? So we're going to go to the g function and replace the x with, this time we'll yell, expression! All right? So here we go. G of expression will equal expression plus 6 all over expression minus 8. All right. I'm not going to make you simplify. Let's at least say this much, though. If you're thinking that you would want to cancel those, 6x minus 2, I would caution you not to do so because they have addition and subtraction attached to them. You would not cancel them if I was going to make you simplify. So, don't worry about simplifying those first questions. Do what I did on the board here. And just trying to keep it simple, all right? When we come back, we'll do an application of this. Why do people put one function into another? Sounds like a plan, huh? I hope you're having a lot of fun with functions.